Hello everyone, this is Mr. Fry back again with part 2 of my video about solving energy transformation questions involving gravitational potential energy and kinetic energy. I'm going to take you through 3 additional problems. This one has a graph that shows a ball rolling from point A to G. It says the ball starts at point A and rolls to point G. And it's got the following questions. It says, at what letter does the ball have the greatest kinetic energy? Okay, I want you to look at the kinetic energy equation that is right here. And you'll notice has two values which kinetic energy depends on, and that is the mass of the object and the velocity of the object. So with that in mind, you have to remember that the mass of the object, since it's the same object throughout the path here, then that's going to stay constant. So the velocity of the object is what's going to let us know what we can put here in terms of what letter represents the point where this ball is going to be moving the fastest. And hopefully you would agree with me here that position D would make the most sense for that, since the ball is going to speed up as it comes down this slope. At this point, it is going to be traveling the fastest of any point on the screen, right? Because once it starts heading uphill again, it's going to start losing that velocity and slowing down. The next question says, which letter shows the ball when it has the maximum potential energy? Okay, so for that, you want to look at the gravitational potential energy equation. Notice that mass and height both determine how much gravitational potential energy something has, as well as the acceleration due to gravity. But since we're assuming this is on Earth, that gravity would be constant. It would be 9.8 meters per second squared. So we have to think about mass as well. That's also just like the last question. It's a constant mass, so there's no change in that. So it's the height that matters here most for this question. So where is the ball the highest above the ground? Hopefully you picked A, so that would make that correct. Okay, and for question C, we have which letter shows the ball when it has the least potential energy. So for that, instead of being the position where the height is the maximum, you would want to pick the spot where the height is at a minimum. And hopefully you're saying position D. So in other words, the position where this ball has the maximum kinetic energy is also where it's going to have the minimum potential energy due to gravity and height. Okay, so the last thing says, why is point G slightly lower than point A? It says, in other words, why couldn't the ball go back to the same height at which it started? Okay, so in this question, we're considering we're not neglecting friction. So the answer to that would be because the ball loses some of its energy due to friction. Okay, in other words, some of its energy here would convert to heat and sound and all kinds of other little things here that can drain a little energy out of the system. Okay, so I'm going to take you to the next question. This is a projectile question, so it's also energy transformation, but the object in question here is a cannonball. Okay, so this cannonball is being launched from the cannon and traveling throughout the path A through E until it hits the ground over here just after E. And in this question, it says, at what letter does the ball have the greatest kinetic energy? Okay, well, kinetic energy, again, since we're assuming this ball has the same mass throughout its flight, in other words, this question's asking, where is it moving the fastest? Okay, there's two places on here where this ball's moving extremely fast. That would be right when it's launched and right before it hits the ground. Since it is closer to the ground here at position E than it is at position A, that would mean that position E is the place where it has the most kinetic energy. In other words, it is traveling the fastest at this point, even though position A would come in a close second place. Okay, this is for what letter shows the ball when it has the maximum potential energy. I didn't mean to click that fast, but just like in the last problem, that potential energy is going to depend mostly on height, and you can see that letter C is the place where that is the highest above the ground. Okay, this would also be the place where the kinetic energy is at the lowest point. In other words, this ball is slowing down and continues to do that until it reaches the apex of its flight, where its velocity would be at a minimum. After that, it would reaccelerate, it would speed up and increase its velocity until it reaches its fastest point right here, which is what we answered here. Okay. The question C says, which letter shows the ball when it has its least amount of potential energy? Hopefully you're thinking about height there again. So the least amount would be where it has the least amount of height. So that would also match up to position E. Again, wherever the potential energy is lowest, then kinetic energy there would be the highest. Keeping in mind that the same energy that's kinetic here after it's launched is being turned into gravitational potential energy as it makes its way toward the top of its flight, and that kinetic energy is dropping while potential is increasing. And then on the downside of that projectile path, you have gravitational potential then decreasing since height decreases, but yet that's turning into kinetic energy since the total amount of mechanical energy has to stay constant. Okay. Then it says what what can be said about the potential energy and kinetic energy at positions B and D, and that's here and here. And if you think about it, they're equal at those positions because at point B, kinetic energy is decreasing, it's slowing down, gravitational potential is increasing, and over here at point D, you have gravitational potential energy decreasing and kinetic energy increasing. Okay, so it's all the same mechanical energy though, so these points would have those two values being equal to each other. And here's the last question. This is a pendulum diagram up here, so if you could imagine this is one object in one string, but it's showing you that position of that as it goes throughout a swing from left to right. Okay, so the pendulum starts over here. Once we release it, it swings all the way to position 5. Okay, it says fill in the table below with the with the following words basically: minimum, maximum, increasing, decreasing, or 0 joules if there's no energy present for that. And it says for the bobs, we're calling this the bob, the GPE and KE at each position. So I've got a little table down here with each position a spot for me to talk about its gravitational potential energy and its kinetic energy. Okay, the easiest place to start on a problem like this would be to make the assumption that since the bob is highest above the ground at positions 1 and 5, that is where the gravitational potential will be at a maximum. So we can go ahead and fill those in. Okay. We can also make the assumption that since when the pendulum swings to one side, that it has to stop before it can change directions and turn around. So at both positions 1 and 5, the kinetic energy would be 0 joules, okay, since the pendulum at those points has to stop in order to then turn around and reverse its motion. So in other words, the pendulum has no joules of kinetic energy. All of its energy then is stored due to its height above the ground down here. Okay. Now the next best place to go here would be to position 3, because that's where the height is at a minimum. So you could make the assumption that the gravitational potential energy would be at a minimum at that point. If that's true, we know that gravitational potential turns into kinetic and then that turns back into gravitational potential again, then we could make the assumption that the kinetic energy at this point would be at a maximum. In other words, that pendulum is moving the fastest right in the middle of its swing. Okay? Right when height is at a minimum, velocity is at a maximum. Now the other two positions, 2 and 4, we can make notes on that as increasing or decreasing for both gravitational potential and kinetic. So if you think about it, we're looking at this swing from left to right just for this diagram, because that's important for these two columns, because these could be reversed if the arrow was going the other way. So the object, when it moves from position 1 to 2, the gravitational potential is decreasing because height is decreasing, and then the kinetic energy is increasing because velocity is increasing. Okay, and if you look at position 4, you're going to see a very similar pattern. Here we have the height is increasing as it goes from 3 to 4 to 5. So that means the gravitational potential would be increasing at that point. Again, this is only if the swing is from left to right as we're looking at it. And then finally, since the height is increasing here, that means gravitational potential is going up. That means also that the kinetic energy must be decreasing. And that makes logical sense, because as something goes towards the top of its swing, it slows down. Velocity is decreasing, so kinetic energy is decreasing. Okay, so we've done that problem. We've solved all 3 of them. I hope this was a help to you. I have put on here a energy graph to try to help you visualize the potential and kinetic energy as a pendulum swings back and forth. You'll notice that kinetic energy on the sides is a 0, which is what we've got here. It's all the way at the bottom. And potential energy is at a maximum at those sides, and that's exactly what we have here. And you'll notice that as they go throughout their swing, you have a decreasing potential and an increasing kinetic. So those are shown here for both directions. So I thought that was a helpful tie-in to include here. Okay, if you found the video helpful, please like and subscribe. I really appreciate you watching, and I hope this was a help. This was Mr. Fry, and I'll see you next time.